There we go. All right, so this problem is asking us to, we're gonna use Newton's second law for the rotational motion, all right? And then they're asking to find acceleration, the angular acceleration. Which is alpha. So that's the letter that we use for angular acceleration. And also, we need to find the velocity after 18 seconds. So I forgot to put that in. So find the velocity, final velocity, because it's released from rest. So the VI is going to be 0. And then we're going to find the velocity after 18 seconds. The block is going to come down with an angular, an acceleration A, okay? And then we're going to find the final velocity when it's released from rest. But the first thing, let's put down some forces. So we have the mg, which is going to be 10 kilograms times 9.8. That's going to be 98 newtons. Right? And we're going to have tension T. Most of the problems are, once you're done with the physics, then mostly is algebra. So it's the algebra that some of you are struggling with, is not the physics. Okay? So we're going to work on that. Mostly is system of equations. That's like you have a whole bunch of equations and then you just plug in. So you need to get used to that. That is the only problem. Because the physics part of it, it's not bad. All right, so we have also, if this is T, this is also T, right? Okay, do we have everything? Okay. So now we're gonna put down some equations. First of all, we're gonna apply Newton's second law to the 10 kilograms. So we have, because this is gonna go down, right? The acceleration is gonna accelerate down. So we're gonna put like down positive. Down positive. So 98 minus T equals to MA, which is 10 times A. All right, this is what you do. Box that, box it, because it's gonna be useful. It's an equation that you're gonna use. So every equation, try to come up with any equation in the system, and then at the end, you're gonna see which one you're gonna use. So this is the first one. The second one, it's gonna be, what is the torque? If I have a tension here, and I have a radius, all right, the radius is 1.5, what is the torque caused by that force? It's the force times the radius, right? And then this is perfect because we have a 90-degree angle. It's a 90-degree angle. Remember that the torque is going to be caused by the force. You multiply the force times the perpendicular distance, So which means we're going to have, since the radius is, we're going to do the sum of the torques is equal to I, which is the inertia of this, because this is a disc. It's a disc. So the disc, we need to remember that the inertia is 1/2 times the mass of the disc times r squared. All right? So that's we're gonna replace that I by 1/2 mr squared, and we already know what m is and what r is. All right? So sigma, and then the sum of the torque equals I alpha. All right, and then the torque, again, the only torque we have is 1.5 times T, the radius times tension. Okay, so we're gonna write 1.5 T equals I alpha. And let's box that. Is there any other equation that we can use? That's it, there is no more. So we're gonna work with these two, but we have another one that relates the angular acceleration to the linear acceleration, okay, is this one. A equals R times alpha. This is very useful because it's going to help us. It's going to help us here. So we have three equations, the one that's boxed. This is not actually, it's like a formula. This is not an equation that we got, but this is a formula. And because R equals 1.5, we're going to write this as A equals 1.5 times alpha. All right, let's see what we're going to do with that. Now, what am I looking for? I'm looking for angular acceleration. I'm looking for alpha, right? But if I can get A, I can also get alpha, right? Because it's related by S. So if I know alpha, I can get A. If I know A, I can get alpha because they are related by A equals 1.5 alpha. Now what's next? Well, we can replace I first. Let's calculate the I.
What's to do?
1/2 times M, which is 18 times 1.5, and then you square that. All right, and that's gonna give you. I'm just gonna get the calculations quickly so we'll be able to solve to get more problems. So when you multiply that, the I is gonna be multiply also I is 20.25. All right, so we're gonna replace that. Let me erase this stuff here since I don't need this anymore. All right, I'm gonna replace I in my equation here. 1.5 T equals to whatever I can substitute, I have to substitute. So I is 20.25 alpha. 20.25 alpha, right? Now, I have the equation, so let me box this now. 1.5 T equals 20.25 alpha. Now I have 98 minus T equals 10A, right? Now, what do I do? Well, I have two equations. I have two variables, T and A. And then this is T, but we can make alpha, we can change it in terms of A by using that equation, right? And then I'm gonna have two equations, two variables. Because the whole thing is about, if you have two equations, you have to have two variables. You can't solve an equation, two equations that has three variables. So what I'm gonna try to do here, because I have three, I have T, A, and alpha, I can change A to alpha. All right, I'm gonna subtract for alpha. All right, so what I'm gonna do, I'm gonna have to change A to 1.5 alpha. So 98 minus T equals 10 times 1.5 alpha. You getting it so far? So now it's perfect. I have to use that equation and this equation that's boxed because they both have T and alpha. If I have T and alpha and I have two equations, that's system of equations. So let me erase that stuff there. Everything is algebra now. Physics is all done. Physics is done. We're just doing the algebra. All right? So let me put down my equations here. Right? I have 1.5 T equals 20.25 alpha. All right? This equation. And I have that one right there, which is 98 minus T equals, now I multiply 10 times 1.5, that's 15 alpha. 15 alpha. All right, I can get alpha now. Look, all I have to do is just express the T in terms of alpha, and then you put the T back here. All right, so let's do that. Look, I can get the T by itself by doing this. Look, I move minus T on this side, T, and then it's going to be 98 minus 15 alpha. Right? Agree? Minus t goes on the right side, 15 alpha goes on the left. But you're going to change the sign. So now I put this t back in first equation right here. So I have 1.5, but instead of t, I'm going to write this 98 minus 15 alpha. So 1.5 times 98 minus 15 alpha, right? 1.5 times t, but t now is 98 minus 15 alpha, equals to 20.25 alpha. Alright, so I'm going to fix that and I get the alpha. That's any questions. No excuse for not knowing how to do that. Alright, we'll just have to solve for alpha. That's an equation, one variable, alpha. And that's what we're trying to get. So let me erase over here. Like I said, the physics part is done, we're just doing the algebra part. Alright. So, I'm going to multiply 1.5 times 98. 1.5 times 98, and then I get 147. Multiply that. And then minus 1.5 times 15. 1.5 times 15, okay, because you got to distribute this. 1.5 times 15 alpha, and minus. So it's 22.5 alpha, all right, we distribute, and then equals to 20.25 alpha. So how do I solve this? Well, I move this on the other side, so I have 22 point alpha plus 20.25 alpha, and then equals 147. All right, let me combine these two, which is 22.5 plus 20.25. They both have alpha, so I combine them. 22.5 plus 20.25 equals to 42.75 alpha. All right, and what do I do now? I divide 42.75 on both sides. All right, and then I get my alpha. That's the first question, by the way, angular acceleration. So alpha is going to be, all right, divide that, you get 147, divide by 42.75, and then I get 3.43. Actually 3.44 because we're going to round it. And this is going to be radian per second squared. Even if it's going to be on the video, okay, you still need to watch. Now, no excuse. I've explained it, and I explained it, and explained it. I gave you the quiz, and then I'm explaining it again. I'm going to give you again another quiz. So, no excuse for not getting it right next time, okay? Because you got to move on. I have a whole bunch of chapters still. All right, so that is the angular acceleration. What's the second question? So let me erase this.
How fast is the block falling after 18 seconds?
Exactly. So alpha, we already found it, 3.44 radian. Remember, this is the unit, radian per second squared. So make sure you have the right unit, radian per second squared. That's part A. Part B is how fast is going to be, the block is going to be going after 18 seconds. So time is 18 seconds. So what's the equation that we're going to use from kinematics?
VF equals VI T.
A third one, exactly. VF equals VI plus AT. You need to know your stuff from kinematics. All right. So VI is 0 because it's released from rest. That means rest. That means from 0. So the VI is 0. So we have VF 0. And now we need to find A because we have alpha. Right? But we have a relationship between A and alpha. A is equal to 1.5, the radius, times alpha. I have alpha, so I just multiply 1.5 by that. So A is going to be 1.5 times 3.44, because I need the linear acceleration, not the angular acceleration. So I always go back to this equation here, which is A equals R, the radius, times alpha. This is always going to convert from linear acceleration to angular acceleration and vice versa. Get it? All right, so VF equals 0 plus 18. Now A, let's calculate that. 3.44 times 1.5. So it's 3.44 times 1.5. 5.16. So I get 5.16 for A. And this is meter per second squared. All right, so I have my acceleration. I'm just gonna plug it in here. So it's 5.16 times, the time is 18 seconds. So I get my velocity, the final velocity is gonna be 5.16 times 18. 5.16 times 18, and then I get 92.88. And this is meter per second squared. I'm sorry, meter per second. So there you go. Done. That's the first video.